The Muscle Cell by Vivian and Brooke.
Stimulus causes the action potential to travel down and arrive at the axon terminal of the neuromuscular junction, which will open the protein channel.
Reaching the axon terminal, the action potential prompts calcium channels to open, flooding the neuron with positively charged calcium ions.
The vesicles carry acetylcholine through the axon terminal and fuse with the neuron into the synaptic cleft, and then attach to the protein channels.
Acetylcholine binds to receptors on chemically gated channels embedded in the muscle fiber sarcolemma. The binding action causes the channels to open.
Binding causes the protein channels to open, allowing a rush of positively charged sodium ions to enter the muscle cell. The arrival of positive charge ion makes the inside of the muscle cell less negative, a process known as depolarization. The sarcolemma, the plasma membrane of a muscle fiber, conducts the action potential across the muscle.
After a neuron fires an action potential, potassium channels open, and potassium flows out of the cell. The outflow of the positive ions makes the inside of the cell more negative again, reversing the earlier spike in voltage. This returns to a resting state is called repolarization, and it helps the neuron get ready to fire again.
The action potential travels along the sarcolemma and down T-tubules. These proteins then activate calcium release channels into the sarcoplasmic reticulum, leading to a rapid and substantial release of calcium ions into the muscle cell's cytoplasm.
When calcium ions flood the sarcoplasm, they bind to specific sites in the actin filaments, causing a big change in that associated protein. This shift exposes the binding sites on actin that are normally covered.
Myosin binding sites are located on the actin filaments, and when the calcium is released, this causes the sites to open so the myosin can attach and cause contraction. The sliding filament theory of muscle contraction is the process where the thin actin filaments slide past thick myosin filaments, causing the sarcomere to shorten. This sliding motion is powered by reattaching and detaching myosin heads to actin, driven by ATP.
The stimulus will stop, the acetylcholine esterase will break down the acetylcholine and change in shape. The action potential will stop. The sodium-potassium pump will reset the membrane potential. Myosin heads detach from actin when ATP binds to the myosin. This weakens the bond between myosin and actin, causing detachment,
which uses ATP to actively transport 3 sodium ions out of the cell and